Hi, this is Sakib Jambhalikar, student of SYCSE. This is a video presentation for I-second activity discrete mathematics. In this video, I will explain about the partial order sets, post sets. The partial ordering is a relation on the set that is reflexive, antisymmetric, and transitive. It is a way of arranging the elements of a set into a hierarchy with some element being more fundamental than others. A relation R on a set A is called as a partial order relation if it is satisfies the following properties. As a relation of R is reflexive, antisymmetric, and transitive. So example on this, consider a set A which having the elements 1, 2, 3 and 4 containing the 4 positive integer, and finding the relation for this set such as R is equals to 2, 1, 3, 1, 3, 2, 4, 1, 4, 2, 4, 3, 1, 1, 2, 2, 3, 3 and 4, 4. So checking for a reflexive, the relation is reflexive as for the every A is belonging to the capital A, and A comma A is belonging to the R, that is the set containing 1 comma 1, 2 comma 2, etc. Checking for the antisymmetry, the relation is antisymmetric as where A comma B and B comma A are both are belonging to the set R. We have A equal to B. Transitive, the relation is transitive whenever A comma B and B comma A both are belonging to the R, and we have A comma C, B comma C and A comma R are whole belonging to the R. The partially ordering sets. The posets are partially ordered sets, which are sets with a partial order relations defined on them. The posets are used in many areas of mathematics, such as algebra, topology, order theory. They are also used in a computer science, where they are used to represent the precedence of a task in a scheduling problem. In addition, the posets are used in the artificial intelligence to represent the structure of a problem and relationship between the elements. So definition, consider a relation R on a set S satisfying the following properties. R is a reflexive, that is R X for every X is belonging to the S. R is antisymmetric, R is transitive also. Then the R is called the partial order relation, and the set S together with the partial order is called the partial order set or poset, is denoted by S relation. So this is an example on the partial order set. From this diagram, we can understand the least member and the greatest member. First, the least member in a such way that y relation x for all and x belong to p is represented by 0, and the greater member such that x belonging to the y and all x is belonging to the p represented by the 1. So minimal, some terminologies, the minimal and maximum member, uh, the upper bound. Let the p order and a is belonging to the p for any element x is belonging to the p is an upper bound for a. Lower bound, an element x is belonging to p is a lower bound for a. Least upper bound, suppose that the A is subset of R is a set of real numbers if M is belonging to the R is an upper bound of A such that the M relation with M bar for upper bound M bar of A, then M is called as a supreme of A is denoted by supreme A. The greater lower bound, consider a non-empty set S of a real numbers R. The set is said to be the bounded from the below if there exists a number W is belonging to the R such that the S is subset of W and S is belonging to the capital S. So moving to the conclusion, So partial ordering and the poset are a powerful tool for representing the structure of a problem and the relationship between its element. They are used in many areas of mathematics such as algebra, topology, order theory, as well as in computer science and artificial intelligence. The partial ordering can be used to define the topology spaces, the limit points, and the partial order algebras. They are also used in a represent of precedence relationships between the task in a scheduling problem. In all of the cases, the partial ordering and poset provide a useful way of representing the structure of a problem and relationship between the elements.